Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today I will discuss about the treatment of incinerators bottom ash. So before that I have discussed about the incinerators, and incinerator is generally a blast furnace which is used to burn out the solid waste which is toxic in nature. So which cannot be those toxic waste which cannot be degraded organically, or those we cannot be used in the composting or in a vermicomposting, that can be burned out in the incinerator. So after burning from the incinerator, with the burning of these solid waste, some these flue gases, some ash will be collected in the bottom chamber of the incinerator. So that ash is also contains some of the toxic elements, because this is the burnout of all the waste. So 80% of this bottom ash that has been collected in the bottom of the incinerator is very much toxic, because it is just the burnout of all the waste which has been generated before that. So let's start this topic with the basic functional element of municipal solid waste management. So in municipal solid waste management, I have discussed this will be worked out with this flow chart, and this flow chart is important to understand. First thing is that from the point of waste generation, waste is generated, then it will be primarily collected, and after the primary collection, it will be goes towards the handling and proper storage of the waste. And with the storage of the waste and its handling, first point will come, that is called as secondary collection. So when with the secondary collection, because first of all the waste has been collected from the point of its source generation, then after the primary collection, it went out through the towards the waste handling and storage location. So with this handling and storage location, secondary treatment will be there, that is called as the secondary collection system will be there. From that point, some kind of curve collection system is there, alley collection system is there. So from secondary collection system, the vehicle will come, this waste hauling management vehicles are there, these vehicle will come and that will collect the waste, and they will go for the transfer and transport. Basically they will transfer, the haul container systems are there, they will transfer the waste from the secondary collection system to its processing unit. Which type of processing unit should be there for that particular waste, and this transfer and transfer is like, so hauling the container from one the secondary collection system to its material recovery facility or material recovery site. And the next thing will come, that is called as processing and transformation. So processing of the waste. So what happened when the secondary collection method secondary collection points are there. From the secondary collection point, the waste will goes toward the either for the processing unit, or it will goes to the transformation. So in the transformation means the waste has been transformed from its toxic characteristics to non-toxic characteristics. So this will be only route. This will be like conversion of waste from toxic to intoxic, means those which is dangerous should be converted into towards the non-dangerous thing. So first of all, some organic waste are there that will go toward the composting site or vermicomposting site, but some plastic material are there, some dangerous things are there that should be burned out into the incinerator. So then the incinerator will come. In the incinerator, it will be burned out, and then after doing all this process, final term will come, that is called as disposal. So after this transformation of waste, either by the vermicompost method or by composting method or by incinerator method, next point will be there, that is called as disposal. So disposal is the final step for this MSW waste generation. So this whole picture will start from the generation of the waste to its primary collection, then its secondary collection, and the final thing is that is the disposal of the waste. And through all these things will involve like the transfer of waste from one location to another location and the hauling of waste from one point to another point. And then what happened, it's the waste processing and the transformation of waste. So after the processing and transformation, the next point is there, that is called as disposal. So this will involves the whole picture of MSW generation. And now today I will discuss about this treatment of this flue gas, this bottom ash. So for the treatment of the bottom ash, one process is there. That process is called as separation process. So first of all, I have already explained what is this bottom ash. In the incinerator, when we will put the solid waste to burn it out at a very high temperature. So by the burning of solid waste, that some ash will be collected into the bottom of the chambers. So that is called as bottom ash. And that should be some treatment methods are there to treat all this waste, that this bottom ash from the bottom chamber. So first is like that separation process we are going to follow. So separation as simplest treatment principle, that will be involved with some physical and chemical processes, or sometimes it will be mixed with the physical as well as chemical. So what happened in the separation process, some sieves will be used. Sieve will be used. That sieve will be having very small particle separation size. So this particle separation size and magnetic separators are there with the sieves, and some magnetic separator are there. So with the magnetic separators, magnets has been used to separate, universally used where the MSW bottom ash is processed for the utilization. So what happened in the particle size separation, some sieve will be used and some magnetic separation is basically used where the MSW bottom ash is processed for the utilization. So in the separation process, what should the main thing which is used first is like sieving will be there, and then magnetic separation of the waste will be there. So the bottom ash typically contains 7 to 10% of scrap irons. Mostly the composition is like that. It will be having 7 to 10% of scrap irons and 1 to 2% of non-magnetic metal. So if 7 to 10% irons are there, so what happened with this magnetic separation, they will separate the scrap iron, and 1 to 2% non-magnetic. So it will be separated by the sieves. So this 1 to 2% will separate by the sieve, and this 7 to 8% will be separated by the magnetic separator. Okay. So this is like the separation process which has been used for the treatment of the bottom ash. And basically what happened, the most composition of this bottom ash is like 7 to 10% of the scrap iron is there, and only approx 1 or 2% is non-magnetic things are there. So basically two process is using, first is the sieve method and second is the magnetic separation method. So with the magnet, the iron will be separated out, and only just 1 to 2% of non-magnetic things are there. So that will be separated with the sieve. So what happened, it is commonly subjected to a very coarse sieving, and sometimes in combination with the crushing to remove oversized material, magnetic separation to remove and recover ferromagnetic materials, and eddy current separation to remove and recover magnetic materials like aluminum and copper. So these coarse sieve are there. Sieve are of fine sieves are there, coarse sieve are there. So sometimes what happen in the combination with the crushing, the oversized particles has been removed. So in the sieve, that sieves are coarse size particle. So with the combination of the crushing, the crushing will be involved, and with the crushing, the oversized materials has been removed. And what happened after that, the magnetic separation are there. This magnetic separation will remove and recover the non-magnetic material with the use of eddy current separation. So eddy current separation is also used to remove and recover the non-magnetic material like aluminum and copper. So this separation method will involve, first is like sieve method will be there, then magnetic separator will be there, and after the sieving, what happens, some coarse particles will be there. So this coarse particle will be separated by using eddy current eddy current in the bottom of the ash. So with that, what happened, the some non-magnetic metals are there, like some aluminum and copper, that has been separated by using the eddy current. So this is just a separation process will be followed. So in separation process, which type of methods are there? First is sieve method, second is magnetic separation method, and then some non-magnetic material. For some non-magnetic material, ET current should be used, and that will be helpful for the separation of aluminum and copper from the bottom ash. So this is about the separation process which is being followed for the separation of bottom ash, which will be like sometimes chemical process will be followed, sometimes chemical and physical process will be followed, and sometimes it will be mixed out with chemical and physical. So this particle size separations are there, that is sheave, and magnetic separation is like that, and it will be used to process and utilization for the bottom ash. Basically, some core size particles are there. These core size particles will be combined with the some crushing, which will be using to remove the oversized particle. Magnetic separations are there, that is going to remove and recover the non-magnetic material. Some eddy currents are there, eddy current separation are there to remove and recover the non-magnetic metals like aluminum and copper. Now comes to the next point, that is next thing will be involved, that is stabilization and solidification. So in the solidification and stabilization, the bottom ash should be solidified, or sometimes it should be stabilized. So this solidification and stabilization is basically a physical process. Physical process will involve, or this mechanical stabilization is there, mechanical process is there. So it will result in a harder or more coherent waste form, which increases the strength and tortuosity of the material and reduces the exposed surface area, thus reducing the rate of release of contaminants. So what happened, this bottom ash should be solidified by some mechanical stabilization. So this mechanical stabilization will result into a harder and more coherent waste form. So this will be results in the form of a like some harder or some more coherent waste form, that is going to increase the strength and tortuosity of the material, and basically it is going to reduces the exposed surface area by reducing the rates of release of contaminants. So it will increase the strength and tortuosity of the material, and like that it will be cannot expose to the outside area, and the reducing the rate of release of contaminants also. Next point will be like stabilization with chemical stabilization. Chemical stabilization is basically aimed at chemical fixation of various contaminants. Means it will be stabilized, it will be fixed the chemical composition of various contaminants by some compounds with very low solubility. So like that, the chemical, it will be like the chemicals cannot release again into the environment. So with that, chemical stabilization process is there. So what happened? Chemicals contaminants are there. These will be required the chemical fixation of the some contaminants by using some chemicals, and these contaminants has been fixed and stabilized with into a compound with a very low solubility, and because of this low solubility it cannot be soluble again into the environment. So this chemical stabilization is important for this toxic chemical ash, because what happened, it will be stabilized with the some contaminants will be stabilized into the compound with very less solubility. Solubility will be very less. So what happened, it cannot be released again into the environment. And next is like solidification and chemical stabilization is like that may be applied separately or in combination at the bottom S. So this solidification and chemical stabilization can be applied separately. It will be when if you are using the stabilization, you cannot use the chemical stabilization, and with a separately in the combination of the bottom S. In sometimes in addition with this stabilization and solidification, the hydraulic binders are there, like some cements that that can be additive to bottom ash, will often results in both solidification and chemical stabilization. So addition with the all these stabilization and solidification things, these hydraulic binders are there. These hydraulic binders are the cements. They are basically what? They are the cement which can be used with the bottom ash, or that will be results into the solidification and chemical stabilization. So this addition of hydraulic binders are there with the cement. Cement is there with or without additive to the bottom ash, and that will often results into the solidification and some chemical stabilization. Now next treatment is thermal treatment. So in thermal treatment, bottom ash can be treated thermally at different temperatures. So this bottom ash can treated thermally with various temperature. Thermally it can be treated with various temperature. What happen when this bottom ash sintering occurs at the temperature approximately 400 to 850 degrees Celsius, and due to that the fusion and reorganization of solid phase are there, and thus they are reducing the availability of various components for leaching. So what happen, they are going to reduce the availability of various components for leaching. So the toxic metal cannot be leached out into the environment because the sinterings at the temperature of approximately 400 to 850 degrees Celsius. This can be cause fusion and reorganization of solid phases. So with that, fusion will be there and reorganization of solid phase are there. So with that, what happen, it is basically it is reducing the availability of various components for the leaching. Next point is melting and vertification. It occurs as a temperature of 1100 to 1500 degrees Celsius, and this melting of the and crystalline and heterogeneous products are formed, and whereas the vertification can may require some additive produces a single amorphous glass phase. So in thermal treatment, melting and vertification is also very important point, because it can occur at the temperature of 1100 to 1500 degrees Celsius or more than it sometimes. And during the melting, by a simple melting process, crystalline and heterogeneous products are formed. Some crystal or some heterogeneous products are formed, and due to the vertification, this may require additives that produces a single amorphous glass phase. The rate of leaching of contaminants from these products is generally slow. So these things has been added to basically to involve the releasing of contaminants again to environment. To stop these contaminants again, it cannot be released back into the environment. So like that, this thermal treatment will be there. This thermal treatment will be like thermally will treat the ash with a very high temperature, like sometimes like 400 to 1500 degrees Celsius. So by this process, by thermal heating, the ash will be mixed with the vertification, and crystallization will be there, and with that crystallization, some heterogeneous product will be formed, and this product may require some additive and produces a single glass phase, and because of that on only, the rate of leaching of contaminants from these products is generally very slow. That's why this thermal treatment is much beneficial, and it will be mostly using for the bottom ash treatment. Like the process, this process is called as vertification. Now next is the treatment of air pollution control residue. So after that, bottom ash, in the bottom ash is there. We have studied the treatment of bottom ash. Now what happened, this incinerator will have some air pollution control devices. So air pollution control devices, how they are acting? APC is like air pollution control devices. So this device will be like, this device will be acting like some separation process will be there. Same, the solidification process will be there. Then thermal treatment will be there. So in separation process, this application of separation process to this residue generally requires the residue or the mass steams to be dissolved or suspended in or saturated with water. That is called as separation process. Means the application of separation process to this residue is basically requires the residue or the mass steams to be dissolved or suspended in or saturated with water. So for what happened, the residue from the dry and semi-dry air pollution control devices are there. So what happened, fly ash will be there. The initial treatment step often consists of or include an aqueous extraction operation regardless of the nature of any subsequent treatment of the steps involved. So this separation process will be basically followed for the air pollution control residue that will be coming out from the thermal treatments, either from the electrostatic precipitator, bag filters are involved, all these processes. So this separation process, solidification, or sometimes stabilization, sometimes thermal treatment will be there. Next is like what happened, some into this bottom ash, some metals and trace elements are there. So it may be removed from wastewater by pH adjustment and chemical precipitation prior to discharge or salt recovery. So this comes under the chemical treatment. Chemical treatment will be given to how by adjusting the pH of the wastewater and some chemical precipitation before it will be discharging into the salt recovery, or it will be discharging into the outside. And this HCl from acid scrubber effluent could be separated by distillation, and chlorine could be produced by electrolysis. So by the process of electrolysis, chlorine will be produced, and this hydrochloric acid from the acid scrubber effluent could be separated by the distillation unit, and then the chlorine will be separated by the process of electrolysis. Next is the, for this air pollution control residues, this next is also stabilization will also follow. So this stabilization will work like that. The residue with some pozzolanic and hydraulic binders like some cement has both a mechanical and chemical effects. This will be having some mechanical as well as chemical effect, but it generally deemed both mechanically and chemically insufficient due to the high salt content. So this stabilization and APC residue with some pozzolanic and hydraulic binders like cement, and both of it having some mechanical effect as well as chemical effect, but it is generally deemed both mechanically and chemically insufficient to the high salt content. So this will be sometime like mechanical will be also there, sometime chemical will be there, and this will be like insufficient for the high salt content. Stabilization and air pollution control residue with some pozzolanic and hydraulic binders like cement is there, and they both are having mechanical and chemical effect, but it is generally deemed both mechanically and chemically insufficient due to the high salt content. These chemical as well as physical both are insufficient because of the high salt content, and stabilization of this APC residue with some pozzolanic and hydraulic binders, it has both both effects are there, and because of that only the high salt and it will be insufficient, it cannot be used more because of the high salt content. Next treatment is again the thermal treatment. So what happened, due to high energy requirement and problems associated with the reformation of hydrochloric acid and vaporization of metal, air pollution control residues are generally not treated by melting process. So hydrochloric acid is there, and sintering process is also there. So in sintering process can be performed on fly ash and some acid gas cleaning residue that has been subjected to aqueous or acid extraction. So with the high energy requirements and the problems associated with the reformation of hydrochloric acid and vaporization of metals, APC residue are generally not treated by the melting of processes. And this sintering process may be performed on fly ash and acid gas cleaning residue that has been subjected to aqueous as well as acid extraction. So in the thermal treatment, because very high energy is required, and the main point is again hydrochloric acid will be formed and vaporization of some metals are there, and these air pollution control residue cannot be not treated by melting processes. And next point is like that the sintering process will be there that can be performed on fly ash and acid gas cleaning residue which have been subjected to aqueous or acid extraction. And now comes to the after the treatment, where again second point is that is called as utilization of this bottom ash. Means we'll study about the utilization. See, after the treatment or before the treatment, that bottom ash can be utilized in some of the sectors. So first sector is the road construction. This bottom ash can be utilized in the road construction. So what happened, how it can be used, this bottom ash substitute sands or fine aggregates in road construction either as a partial or full replacement due to its similar properties to natural sand, because it is having the same properties with the natural sand. So like that it can be used, this bottom ash substitute can be mixed with the natural sand and it can be act as a fine aggregate in road construction either as a partial or full replacement, and sometimes it will be having similar properties to the natural sand. Bottom ash can be used as sub-base. Bottom ash can be used as a sub-base and road-based material and as a bituminous mix for binder layer. So this bottom ash can be used as a sub-base, means like it can be used as a base with a cement or with the road-based material. Either basically some materials are using. So with that material, it can be used as a base, as a bituminous mixes for binders or for layer mixing. And next is the bottom ash provides adequate bearing capacity for lower strength application like sub base materials and embankment fills. So in the construction, it can be utilized as a substitute as a sand or a fine aggregates in road construction, and it can be also used as a sub base or road based materials as a bituminous mixes. It can be used as a sub base or road based materials as a bituminous mixes. And next is like that this will be providing adequate bearing capacity for lower strength applications such as sub base materials and embankment fill. It can be used as the adequate or bearing capacity for lower strength applications and sub base materials and embankment fill. Now comes to the aggregate replacement in the concrete. This can be used as a replacement in the concrete. It can be used as an aggregate. This bottom ash can be used as an aggregate in the concrete. Like that, bottom ash can be either used in a fine or coarse aggregate replacement. It can replace as an aggregate in bottom ash. So how it will act? It will act like a fine or coarse aggregate replacement. The replacement will cause some changes on the properties of concrete like workability or sometimes compressive strength and durability. So these changes, this addition of this coarse aggregate replacement, the workability, compressive strength and durability will be increased, and that will be changed in the strength of the concrete. So it will be helpful also. By the addition of this bottom ash, the replacement, it will be changed the properties of concrete in terms of the workability, compressive strength and durability. So next is the fly ash. Fly ash is also collected into this bottom ash. This fly ash can be used in the building material as a cement. This is the sectors where we can utilize the fly ash, where we can utilize this bottom ash. So it can be used in the clay bricks. It can be used in the brick making. This fly ash brick is used in the brick making nowadays, and that that brick can be used in the parking location or in the some portico making, like that. Cellular concrete, it can also act as a cellular concrete. Sometimes it is using in the hollow brick, emulsion paint and partial replacement of cement or manufacturing of cement. So this fly ash can be utilized in many sectors. First of all, it will be utilized as a building material. It can be used in the clay bricks, cellular concrete, hollow bricks and emulsion paints and replacement of cements or manufacturing of cement. So these are some of the sectors where this fly ash can be used or it can be utilized. Now next is it can be utilized in the soil stabilization. For the stabilization of soil, the physical and chemical alteration of soil to enhance its physical property. Soil fly ash is having high bulk density. fly ash is having high bulk density. So when we will add this fly ash into the soil, this is going to increase its physical property. The binding of soil with each other will increase by adding fly ash. So that will help when in the soil erosion. Erosion cannot take place when we will add fly ash into the normal soil, and it will stabilize the physical properties of soil. And uses of fly ash for soil stabilization increases basically the shear strength. Shear strength of the soil has been increased, and it controls the shrink and swell properties of soil and improve load bearing capacity. So the shear strength will be increased, and because of increase of the shear strength in the soil, the shrink and swell properties of soil will increase and improve the load bearing capacity. So this is called as soil stabilization. This soil stabilization can be achieved by adding fly ash into the soil, and this fly ash is going to improve the chemical and physical characteristics of the soil. Next is the waste treatment. Fly ash can be used in combination with other alkaline materials to transform the sewage sludge into organic fertilizer or biofuels due to its alkalinity and water absorption capacity. Fly ash can be used in combination with other alkaline materials to transform sewage sludge into organic fertilizers or sometimes biofuels due to the alkalinity and water absorption capacity. So this is also a other sector where we can utilize the fly ash either in a soil stabilization or in the waste treatment process. Next is some of the problem. We can utilize the fly ash in some of the sectors, but main point is that what is the problem that is associated with the fly ash? What are the negative properties of the fly ash? So because of heavy disposal, fly ash is too much amount it has been generated. So because of its heavy disposal, these particles can be used both as a dry ash and pond ash. It can be used in the dry ash, either in the pond ash, that is going to acquire hectares of land in the vicinity of power station. So what happened? Because of too much generation of this fly ash is occupying, capturing too much hectares of lands in the vicinity of the thermal power plant. Because of its fineness, it is very difficult to handle fly ash in the dry state. Flying fine particle of ash corrode structural surfaces and affects the horticulture. So it is a very fine particle, and because of its dryness, when it was in dry state, it will be very tough to handle this fly ash, and flying fine particles of ash corrodes the structural surface, and it will be mostly affect the horticulture of that particular area. It disturb the ecology, slow air and water pollution. Means this fly ash will causes all three type of pollution. Fly ash will causes all three type of pollution: air pollution, water pollution, and soil pollution. And long inhalation of fly ash can causes various diseases like silicosis, because silica is there in the fly ash, and with the inhalation that silica will deposit on the lungs. That is called as silicosis. And fibrosis of lungs, bronchitis, pneumonitis. So some disease is also associated with this fly ash problems. This disease will be like caused due to the long inhalation of fly ash, and causing various diseases are very serious and dangerous diseases. Next is when we'll utilize this fly ash in the agriculture. So what is its advantage? It contains almost all essential plant element, as I have already discussed that fly ash will contain all essential plant nutrients like micronutrients like phosphorus, potassium, calcium, magnesium and sulfur, and some micronutrients like iron, manganese, zinc, copper, cobalt, boron and molybdenum, except some organic carbons and nitrogen. So these contain almost all the essential plant nutrients, microelements, macroelements, all type of elements are there in the fly ash. It will be useful for the stabilizing erosion prone soil, and phytoremediation can prevent this cycling of toxic and from fly ash and growing of multi-purpose tree species on the problem soil. So plantation, it can be help in the plantation. This fly ash will having a very much advantages in the agriculture, because it will consist both micro elements and macro elements that will be required by the plant nutrients, and it will be helpful in the stabilization of erosion prone soil, and it will sometimes prevent cycling of toxicant from fly ash and growing of multi-purpose tree species on the problem soil. So these are the advantages that has been related with the fly ash, and these fly ash, when we are going to use the fly ash in the agriculture, so how it will be helpful to us. So, these are the references of some of the textbook that you can utilize for the further study, for the deep study of all these topics. So this in this topic I have discussed about this fly ash management and the bottom ash treatment. So if you have any query, if you have question, you can write me on the given mail ID shikha.pandey@gmail.com and thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.